Okay, so from this graph, we know that we're gonna get the same thing on this other side. And it's gonna look like this. Okay, so now let's look at the end behavior now that we have a graph to look at. So end behavior, as x approaches infinity, our y, what's happening to our y? So as my x is approaching infinity, my y is approaching the x-axis, which is 0, but it's doing that from above, right? So it's approaching 0 from above, so I'm going to put a little positive on top of it. Now, what about as x approaches negative infinity? As it approaches negative infinity, so in this direction, my y value is again getting really close to 0, but it's doing that from below. So I'm going to say y reaches 0, but from below. Now, we said there's one other behavior we have to look at, which is the way the function is behaving around the horizontal asymptote. That's the line on, it's a vertical line. It gets really close to it, but never touch. So in this case, it's probably just -2. So here with the function, I'm going to say as x approaches this line, sorry, -2, but as it approaches from left, we want to see it from the left and the right side. So let's do positive, then my y value is going towards infinity. So as my x is approaching this line from the positive direction, which is from the right side, moving this direction, my y value is increasing, going to the infinity. And as my x approaches -2 from the left side, then my y value is going towards -infinity, right? So there we go. We got all our behaviors. Now, we would like to be able to sketch the reciprocal function without having to sketch the original function. First, to do this, we must first introduce some proper definition. So the vertical asymptote we were talking about, we talked about is a vertical line the function can approach but never touch. It is found by setting the denominator equal to 0. And here we can see that we sort of inadvertently did that, right? When we put -2 plus 2, we got 0. Our denominator became 0, and that's when it's undefined. And that's so we knew that, okay, we can't have any points on this graph when x is -2, because then our y value for the reciprocal function is undefined. It doesn't exist. So a vertical asymptote is a vertical line the function can approach but never touch. It's found by setting the denominator equal to 0. And then solve for x. So in this case, we could have found the vertical asymptote by our denominator is x plus 2. So setting it by equal to 0 is x plus 2 equals to 0. And then we have to solve for x. So our x equals -2. And that's my vertical asymptote. Now, there's also a horizontal asymptote. That's a horizontal line we can draw on our graph that will not cross any other function. So the horizontal asymptote is a horizontal line the graph approaches as x approaches positive infinity and negative infinity. If the numerator contains no x, which is the functions we've been working with so far, they've all been 1 over a linear equation, then the horizontal asymptote is y equals 0. The horizontal asymptote is y equals 0. So we can see that in this graph as well. My y equals to 0 is essentially my x-axis. And we can see that our graphs get really close to our x-axis, but never quite touch it. And that's also why we look at y equals to 0 over here. So let's do some examples. State a vertical and horizontal asymptote for each of the following functions. Y equals 1 over x, 1 divided by x minus 3. So let's look at vertical asymptote first, which is I just have to set the denominator, this part equal to 0. So x minus 3 equals 0, x equals 3. And therefore my vertical asymptote is at x equals 3. Okay, and what about horizontal asymptote? So for horizontal asymptote, they said that if the numerator contains no x, doesn't contain any x, check. Therefore, my y just equals 0 for horizontal asymptote. Let's move on to this one. So for my vertical asymptote, again, I have to set the denominator equal to 0. My denominator is 2x plus 1. Equal to 0, 2x equals negative 1, x equals negative 1 over 2. Okay, so this is the equation for my vertical asymptote. And for my horizontal asymptote, again, I look at the numerator. I don't see any x, contains no x. Therefore, my horizontal asymptote is y equals to 0. Last one, let's look at g of x. So my denominator, again, to get the vertical asymptote, I'm going to make it equal to 0. So 12x minus 3 equals to 0. And my 12x equals to 3. And then x equals 3 divided by 12. So x equals 1 over 4. So this is the equation for my vertical asymptote. For horizontal asymptote, again, I look at the numerator. I don't see an x, therefore my horizontal asymptote must be y equals 0. Okay then, let's solve a proper question. Let's do it over here just because there's more space. Let's first start here. Okay. So let's solve this function. F of x equals, this is our function, f of x equals 1 over 2x plus 3. So first question A, state the vertical and horizontal asymptote. We just did that, pretty easy, right? So my vertical asymptote, again setting the denominator equal to 0, is 2x plus 3 equals to 0. 2x equals negative 3. X equals negative 3 divided by 2. Okay, so this is the equation for my vertical asymptote. And for horizontal asymptote, I'm going to look at the numerator again. I don't see any x, so my horizontal asymptote must be y equals 0. Okay. Great. Let's start plotting these in. So I know at the line x equals negative 3 over 2. Let's say this is 1, this is 2, negative 1, negative 2. So it would be right over here. I'm going to draw these lines orange. So at x equals negative 3 over 2, I am drawing a line that represents my vertical asymptote. So this is vertical asymptote, and it's at x equals negative 3 over 2. Okay, and my horizontal asymptote, I also want to draw that in, is y equals 0, which is just my x-axis. I'm going to draw a line on that too, and I'm going to label it as my horizontal asymptote when y equals 0. Okay, let's move on to the next part, which is B. State the x and y intercept if they exist. So I'm sure we're all familiar with this. So to get the x-intercept, I am going to make my y equal to 0, and that's just 1 over 2x plus 3 equals to 0. And I'm going to solve for x, and to do that, I would have to multiply this by both parts to get rid of it, but then it will be 1 equals to 2x plus 3. When it comes over here, it gets multiplied by 0. But this is undefined. You can't have 1 equal to 0, right? Because this whole thing would go to 0 if it's multiplied by 0. And therefore, this is undefined. And so I don't have an x-intercept. None. Okay. What about y-intercept? For my y-intercept, I'm going to make x equal to 0. So 1 over 2 times by 0 plus 3 equals 2 times 0 is just 0, so I'm left with 1 over 3. So I know when x is 0, my y is 1 over 3. So I have a point. So let's plot that in too. Let me just 1, 2, -1, -2. Okay, so when my x is 0, my y is 1 over 3. So around here. Okay, so I plotted that point in as well. And I know that I don't have an x-intercept, which makes sense because at y equals to 0, which is my x-intercept, that's where my horizontal asymptote is. So I would not be able to have a point on there. Okay, so this is what I have. So the next part, C, says state the points where the function is 1 or -1. So to do that, I'm just going to make my f of x equal to 1 and then equal to -1. So 1 over 2x plus 3 equals to 1. That would be 2x plus 3 equals 1. And my x would equal -1. So I know I have a point when x is -1, my y is 1. Okay. So that's the first part. Let's do it for -1. So that's when my function 1 over 2 of x plus 3 equals -1. And that just becomes -2x minus 3 equals to 1. And -2x equals to 4. X equals -2. There we go. So then I also know when x is -2, y is -1. Okay, so I got 2 more points. Let's plot those in. When my x is -1, my y is 1. There's a point there. When my x is -2, my y is -1. There we go. There's a point there. So based on this, you could base from the other graphs that we worked on, from the other graphs we worked on, you could guess that the graph is going to do it with a pencil. The graph is probably going to behave something like this, just because those are all the reciprocal functions we've seen so far. But here is how you know that so it says sketch the graph. We kind of did that, and then stay in domain and range. But so to know how it actually behaves and figured it out, what you need, because we don't have space, I'm going to move on here. So this is how we solved that graph so far. Got the vertical asymptote, horizontal asymptote, x-intercept. We didn't have one, y-intercept. We got the points. Let me put it this way. You can see both. And we got the points for when a function equals y and -1. But now we want to see, how does it behave? How does the end behave? It's kind of like when we're graphing those other ones, based on whether the degree of the polynomial equation and whether it was positive or negative, even or odd, we could figure out how it would behave, how the graph was behaving, and figure out the end behaviors. So to do that for these reciprocal functions, we want to draw something like this, which is the same as when we had our x-axis and the y-axis. When we found our y values based on the x value, like this, as we do for almost any graph when we want to graph something. But for these reciprocal functions, when we want to figure out the end behavior, you go with, as x approaches these values, we want to see what's happening to y, in what direction is y moving. So to do that, first we're going to look at our vertical asymptote. Our vertical asymptote was 3 over 2, negative 3 over 2, but we want to see how the graph behaves. So here we go. So this is before, sorry, so I'm just going to erase the pencils. So this is what we know so far. We've plotted it in, we know our vertical and horizontal asymptote, but that was just an assumption how it's behaving. You could make that assumption based on other graphs, but it won't always work. And the proper way of doing that so is to see, okay, how is my graph going to behave as it gets really close to my vertical asymptote from both the right and the left direction, right? So I want to see which direction is our graph going to go. So to see that, we're going to put our vertical asymptote, which is negative 3 over 2, from the positive direction. Can you see both? From the positive direction, this is the positive side of my graph. So that's from the right side, and from the negative direction, from the left side. Okay, so to do that, I'm going to pick a point that gets really, really close to negative 3 over 2 here, but is on the positive side of it. So, but that is on the positive side. So I'm going to pick negative 1.4, and I'm going to just plug it in. 1 over 2 times by negative 1.4 plus 3, I'm going to get 1 over 0.2. So as it's getting closer to this, I'm going to get a smaller and smaller number, and the more I divide 1 by a smaller and smaller number, it's going to go to infinity. So as x approaches negative 3 over 2 from the positive direction, my y is going to go towards infinity. Now, as x approaches negative 3 over 2 from the negative side, I'm going to plug in negative 1.6. When I do that, I get 1 over negative 0.2. So it's going to approach negative infinity. The smaller you divide 1 by a really small number, smaller the number, the larger it gets, and so negative infinity. Now, I'm also looking at this graph now, so I know that as x approaches 3 over 2 from the positive direction, it's going to go towards infinity, okay? And when it approaches negative 3 over 2 from the negative side, it's going to approach negative infinity, okay? But now I need to know, how does my graph behave as it approaches this horizontal line here? To do that, I need to see how my y is going to be when my x goes to positive infinity and negative infinity. So here, I'm going to do positive infinity and negative infinity. And I'm just going to pick a really large number. I just went with 1,000. So if I plot in 1,000 in here, it will be 2 times by 1,000 plus 3. So 1 divided by a really large number. So if I divide 1 by a really large number, I'm going to get a really small number. The value is going to get smaller and smaller, but it's never going to be quite 0 because I'm still dividing 1 by a really large number. I'm going to get a really small number, but never quite 0. So my y is going to approach 0, but never quite be 0. It's going to approach 0, and because it's a positive value, it's going to be from the positive side. Whereas negative infinity, if I plug in negative 1,000 here, it's going to be 1 divided by a negative, it's technically a very small number because it's negative, but it's going to be like negative 10,000, negative 1,000,000, which is going to get me really close to 0, but from below. So going back here, I can say that as my x approaches infinity, in this direction, my y is going to approach 0, so it's going to get really close to 0 from above. So it's going to be like that. And then as my x approaches negative infinity, my y is going to approach 0, but from below. There we go. So now I can connect them with the points I already had on the graph. And I get that. So that was sketching the graph of the function. Sorry, you guys to see. The last part is stating the domain and range of the behavior. So our domain is our x values. So we write it as domain equals a set x values, which can be any real number, except we know that x can't be negative 3 over 2, right? Because at x equals negative 3 over 2 is where we have our vertical asymptote, and we can't have a value on there. And for our range, your range is all the y values. So again, I'm going to say my y can be any real number, but because we have a horizontal asymptote, we know that our y cannot be 0. We cannot have a point at y equals to 0. And there we have it, our domain and range. So try the practice problems. You don't have to do number 1, but try 2, 3, and 4. Yeah, good luck.